So now next topic is that completes the first derivative and second derivative. Now we will talk about how to find line integral, surface integral and volume integral. Let us see, you have line, surface and volume integral. So we have to see how to find the line integral. So again, some vector field is given. And in this vector field, a particular path is specified. Let's say we have a point. This point is A and this point is B, and this path is specified. So you have to find line integral in some vector field. And that vector field, it may be an electric field or magnetic field, that we will discuss. So in general, I am taking some vector field A. So how to define line integral in this vector field? You have to divide this path into elemental length dl1, dl2, dl3 and so on. Divide whole path from A to B into elemental length. And you know dl vector, that is infinitesimal displacement vector. So from A to B, you have to divide this path into elemental length. And then find A dot dl1 plus A dot dl2 plus A dot dl3 and so on. And it's a continuous path from A to B. So line integral over this path is given by integral A dot dl from A to B. So dl, you know, in different coordinate system. So depending on vector A and the given symmetry, we will find line integral in different coordinate system. In this case, this is an open path. This is an open path. You know that path may be open or it may be closed. If you have an open surface that is surrounded by closed line. So if you have a closed surface, if we have closed surface, then line integral over the closed surface is given by closed A dot dl. This represents the closed line integral. So we can find line integral on an open path or closed path. When point A and B coincide, path is closed path. Now you will encounter two types of
closed
field.
path.
When point A and B coincide, that is the closed path. Whenever you have an open surface, you will get always a closed path. So we will see how to calculate it. This is the representation of closed path. Whenever this given circle is given with this integral, that means it represents a closed line integral. Now this vector field may be a conservative field or non-conservative field. So if field is conservative, how we will check whether it is conservative or not? So there are different properties. So for conservative fields, you can check that curl of that vector must be 0. If curl of A is 0, then that field is conservative in nature. And in conservative field, if you calculate line integral, you will see line integral is independent of path. When field is conservative, you will see line integral is independent of path. And then what will be closed A dot dl in a conservative field?
0.
That is always 0. So you have to remember these properties in a conservative field. If non-conservative, then you will see curl is non-zero, line integral depends on path, and closed line integral is non-zero. So in different case, we will calculate the line integral. So I have just defined line integral, and in different examples, we will see how to calculate it even in Cartesian coordinate, in spherical polar, and in cylindrical coordinate. Let us see how to define surface integral. Now we have to define surface integral in some vector field. So again, some vector field is given. This vector field is A. So that is given, and a particular surface will be specified. Whenever you have to find surface integral, a particular surface will be given. Let's say this surface is given, and we have to find that surface. Maybe again it may be open or closed. You know, whenever you have a volume that is surrounded by closed surface, and when you have an open surface that is surrounded by closed line. So let us take this is an open surface, and you have to find surface integral over this surface in this vector field. So what you have to do, you have to divide this surface into elemental area. Let's say this is dA1, then another elemental area dA2, and so on. Whole surface is divided into elemental area dA1, dA2, and so on. Then you will see A dot dA1 plus A dot dA2, and so on. So this surface integral is the double integral, because you have two variables in the area element. Or in short, you can write this as A dot dA. Whenever it is written as surface integral, it means this is the double integral, because in area element you have two variables. So again, you can find in different coordinate system like Cartesian, spherical, polar, and cylindrical. This is for open surface. When surface is open, and for closed surface, when surface is closed, this integral is represented by closed A dot dA. This represents the closed surface integral. So you can define on open surface as well as closed surface. So what does these integral represent? You will see what does line integral represent. So in electrostatic field, if you calculate F dot dl, let's say force on the charge particle is F. So if you have to find work done, so we will calculate F dot dl. So when this A is the force in electrostatic force, then F dot dl give you work done in the electrostatic field. Similarly, you will see what does surface integral represent. So if you replace this vector field A by electric field, we will define E dot dA as the electric flux. If you replace vector field by a magnetic field, you will see B dot dA will give you magnetic flux. So here I am just introducing how to calculate line integral, surface integral or volume integral, and then we will see its application in electrostatics and magnetostatics. Is it clear? And you know how to write dA in different coordinate system, so you can easily calculate it. And we can also calculate volume integral. So what will be volume integral? So we have some scalar function is given. Some scalar function is given. Let's take that scalar function is f. F is the scalar function and a particular volume is given. A particular volume is given. And we have to find volume integral over this volume. So that integral is simply given by, you have to divide that volume into elemental volume, and you know elemental volume is d tau. So just find f d tau. And this is the triple integral. Actually, this integral is triple integral because you know d tau has three variable x, y, z, r theta phi or r phi z. So this defines the line integral. You have to divide the volume into elemental volume, multiply with f, then add up. It's a continuous volume. So you will get volume integral over f. Now you will see in electrostatics, when this scalar function is a charge density. Let's say this scalar function f is rho. So what is rho? Let's take this example as a charge density. This is charge density. So what does this integral will represent? That will give you total charge. This volume integral rho d tau, this will give you total charge. So when charge density is given in a particular volume and you have to find what will be total charge contained in a certain region, just use volume integral, you will get the total charge. Is it clear?
Sir. Yes, sir.
Now, practically, this is the practical case where you have to calculate the total charge. But theoretically, we can also define volume integral over vector. This is volume integral over scalar. So we will talk about this case only. But theoretically, you can also define volume integral over vector. So let us see how you will define. Let vector A is ax x cap, ay y cap, az z cap. And we have to define volume integral over a vector. Theoretically, we can define. So that is a d tau. And what does it mean? Actually, you have to calculate integral in component form. So first component will be x cap component. then this component is AY component, and next component is AZ component. So theoretically, you can also define volume integral over vector, but in component form. So actually, AX is a semi-scalar value. So you can calculate it, and that will be the component of X cap. Similarly, Y cap component and Z cap component. This is valid in Cartesian coordinate only. Valid in Cartesian coordinate So if vector A is given in different coordinate, like in spherical, polar and cylindrical, and you have to define volume integral, so first you have to convert that vector in Cartesian coordinate, because this is defined in Cartesian coordinate only. So whenever A is given in spherical, polar or cylindrical, just transform it into Cartesian and then you can write this integral. Is it clear? So we have defined line integral, surface integral and volume integral. Yes?
Sir, can you explain again the charge density?
I have taken one example. Here I have taken general case that you have any scalar function f. Let's take in electrostatic, we will consider that a scalar function is a charge density. For example, let's say you have this dielectric sphere is given, and let's take its charge density rho is some value k into r, and you have to find what will be total charge in this dielectric sphere. So what you will do, you have to find volume integral. So I have taken one example, and we will calculate this when we will talk about electrostatic Gauss law. Is it clear?
Okay. Thank you, sir.
I have given you just what does this represent. For example, line integral, I told you in electrostatic field that will give you work done. Surface integral in electric field will give you electric flux. In magnetic field, it will give you magnetic flux. Now, what does this volume integral represent? So, if you take example of a stationary charge, that will give you total charge in certain region. Is it clear?
Yes, sir.
Sir, we can do this vector integral in some other coordinate system also, right? We'll take R
This volume integral.
components.
This volume integral.
Yes, sir. Yes, this one.
This is valid in Cartesian coordinate only. If let's say vector A is given in spherical polar coordinate, so you cannot write this component r cap, theta cap, phi cap. You have to first convert in Cartesian and then you can write this. In last class, I have also discussed how to operate del square A on vector. So that is again valid in Cartesian only, not in theta and phi. Just remember this.
Okay.
So now we will define fundamental theorem of gradient, divergence and curl, and then in these theorems we will also calculate, we will verify these theorems, and in these theorems we will also calculate line integral, surface integral and volume integral. So we will start with fundamental theorem of gradient, divergence and curl, and then we will see how to calculate volume, line and surface integral. So let us first see what is fundamental theorem of gradient. We have to see its statement and then we have to verify these statements using the different examples. Let us take V is some scalar function. V is some scalar function. Let us take V as a scalar function. This is some scalar function. So what does this represent? You can write line integral of a gradient of some scalar function v on an open path from point A to B is always independent of path. Is always independent of path. Because you can see right hand side is independent of path. It only depends on value of the function v at endpoint. It only depends on value of the function v at endpoints. That is vb minus va. So this is the line integral of a gradient of some scalar function. So that is always independent of path. And value of this integral depends on value of the function v at endpoints. So in objective question, if you have to find this integral, instead of calculating this, just find vb minus va. That will simplify your calculation. So using these theorems, we can simplify our calculation. So this is on open path. What will happen when path is closed? What will be closed? Gradient v dot dl. What will be this value according to gradient theorem? Closed line
Zero.
means a and b will coincide. So that is always 0. So you have to remember a statement of this theorem. Now we will take different examples and then we have to verify this theorem. So let us take first example. Let us consider function v is given, that is x square plus 4xy plus 2yz cube. This is the scalar function and point A is 0, 0, 0 to another point B is 1, 1. These 2 points are given. Verify gradient theorem along path A is 0, 0, 0 to 1, 0, 0. Then you have 1, 1, 0 and then 1, 1, 1. Along different paths, you have to move from A to B. And then you have to verify this theorem. B is 0, 0, 0. Then you have 0, 0, 1. 0, 1, 1. And again 1, 1, 1. So in each case, you have to move from A to B. And then C part, you have a direct straight line from A 0, 0 to B, that is 1, 1, 1. So let us verify this theorem.
So straight line from 0,
Is
0, 0.
Just connect A to B by a straight line. You have a direct straight line from A to B. So what again you have to find, you have to verify along this path also, you have to verify gradient theorem. Is it clear?
Yes, sir.
So we have to see its solution. So let us first calculate right hand side, because integral value must be fixed according to the gradient theorem. So what will be VB minus VA? In this case, VB minus VA. So that is V.111 minus V00. So V11, this will be 1 plus 4 plus 2 minus 0. So this value is 7. So integral value must be 7. Is it clear? Integral value from A to B must be 7, because that is VB minus VA. So we have to verify it. That will verify the gradient theorem. So let us consider along path 1. So divide this path from A to B in different segments. So let's take, this is segment 1, this is segment 2, and this is segment 3. And along each segment, we have to find the line integral. So let us see this path from A to B. So this is X, Y, and Z. So this point A is 0, 0, 0. Then segment 1 is 1, 0, 0. So you have to move 1, 0, 0. Then you have to move point 1, 1, 0. And then you have to move point B, that is 1, 1, 1. So you have segment 1 here. This is
Board
segment.
is not visible.
That is not visible.
It's not visible.
So let us see, draw. So you have to see so this is the path. X, Y, Z. This is A. A is 0, 0, 0. This point is 1, 0, 0. This point is 1, 1, 0. And this point is B, that is 1, 1. So you have 3 different paths. Segment 1, this is segment 2, and this is segment 3. So now you have to find gradient V dot dl, because left hand side is gradient V dot dl. So first calculate gradient of V. You know how to calculate gradient of V. So what will be gradient of V? Del V by del X is 2x plus 4y x cap. Then del V by del Y is 4x cap plus twice z cube y cap. And del V by del Z is plus 6y z square z cap. So this is gradient of V. Now segment 1. You can see segment 1, you have to write dl vector. So you have to first see how x, y, z varies. So in this case, x varies from 0 to 1. y is 0 and z is 0. So what does it mean? dy dz is 0. So what will be dl vector? Simply dx x cap, because dl in Cartesian coordinate is dx x cap, dy y cap, dz z cap. But since y and z is 0, so dy dz is 0. So this is dl vector. And if you know dl, you can write gradient v dot dl. So if you take dot product with x cap, you will get only first term, that is 2x plus 4y, and y is 0. You can see this y is 0 here. So when y is 0, this will give you twice of x. So along this segment, gradient v dot dl is 2x. So this integral will give you segment 1, this integral will give you what will be gradient v dot dl along segment 1. You have segment 1. So this will be twice x dx. X varies from 0 to 1. This is the line integral over segment 1, gradient v dot dl. So this will give you 1. So that is the line integral along segment 1. Now you can find along segment 2. So along segment 2, just see x is 1, y is 0 to 1, z is 0. So dx is 0, dx dz is 0. So dl will be dy y cap. dl will be dy y cap. So what will be gradient v dot dl? What will be gradient v dot dl? So this gradient v is given. Take dot product with y cap. So you will get 4x plus twice z cube. Now z is 0 here. This z is 0. You can see this z is 0. So this will give you 4x. So integral 4x dx 0 to 1 is, what will be this value?
Sir, here DL is the dy y cap. no, sir?
dy y cap. So you will get
X dy.
dy होगा.
4x.
X is also 0 now.
4 dy.
This must be 4x plus dy. Okay. This is, just see. So this is dy. Z is 0 and x is 1. So this will be 4 dy. Is it clear? Z is 0 and x is 1. So that will give you 4 dy. So integral will be 4 dy. And y varies from 0 to 1. So this integral is 4. So line integral
dx is equal
yes,
y dx is equal to dz.
because x is 1. So what will be dx? 0. X is constant. So dx will be 0. Z is 0. So dz is also 0. So dx, dz
Okay,
both are 0. Just see, x is 1, z is 0. So dx, dz both are 0. So in line integral, variable is y. So you will get only dy y cap. Now you have to see segment 3. So segment 3, you have x is 1, y is 1, and z varies from 0 to 1. So in this case, dx dy will be 0. So dl is dz z cap. dl is dz z cap. So what will be gradient v dot dl? So you will get last term 6y z square dz. Put y is 1. This y is 1 here. So you will get 6z square dz. So now this integral will give you integral 6z square dz. 0 to 1 is 2. So this value is 1, this integral is 4, and this integral is 2. So finally, what will be A to B gradient v dot dl? Segment 1, 2 and 3. Add line integral along these 3 segments. So 4 and plus 2, and that will be 7. So you can see VB minus VA is also 7, and gradient V dot dl is 7. So that verifies the gradient theorem. That line integral,
सर ये 7 कैसे आया? सर ये VB minus VA 7 कैसे आया?
VB minus VA, function V is given as a function of XYZ. So V11, put XYZ1. So you will get 1
Sure.
plus 4 plus
Okay,
2
okay,
minus
sir.
0. Just put value of XYZ. So at 0, 0, 0, it is 0. Okay? Now you have, that is along first path. Similarly, let us find along second path. You will see line integral of gradient is independent of path. Gradient V dot dl is always independent of path. So let us see along second path. So VB minus VA is same, 7 value. Now let us see second path. XYZ point is 0, 0, 0. This point is 0, 0, 1. Then this point is 0, 1, 1. And then again you have to move to point B, that is 1, 1. So this is segment 1, segment 2 and segment 3. Again along these 3 segments you have to find the line integral, gradient V dot dl. So I have already calculated gradient V, that is twice x plus 4y x cap plus 4x plus twice z cube y cap and plus 6y z square z cap. This is gradient of V. Now along, so B part, segment 1, again this is segment 1, segment 2 and segment 3. So segment 1, this is B part, segment 1. So x is 0, y is 0 and z 0 to 1. So you will get dx dy is 0. Now dl is dz z cap. dl is dz z cap. So what will be gradient V dot dl? Gradient V dot dl is simply last term you will get 6y z square dz, and you can see y is 0. So put y 0. So this integral will be 0. So along segment 1, line integral will be 0. Then segment 2. In segment 2, you will get x is 0, y is 0 to 1, and z is 1. So dx, dz is 0. So dl will be dy y cap. Now gradient v dot dl. Let us see gradient v dot dl. So gradient v dot dl will be
2 dy.
4x plus twice z cube dy, and condition is x is 0 and z is 1. This x is 0 and z is 1, so this is 2 dy. So what will be this integral 2 dy 0 to 1? That is simply 2. Now segment 3. Segment 3, x 0 to 1, y1 and z1. So dy dz must be 0. Dy dz is 0. And dl is dx x cap. So gradient v dot dl. So gradient v dot dl is twice x plus 4y dx. So y is 1. So this is twice x plus 4 dy dx. So now integral will be twice x plus 4 dx 0 to 1. So this will give you x square by 2, 1 plus 4, that is 5. So values are 0, 2 and 5. So A to B, gradient v dot dl will be 0 plus 2 plus 5. Again 7. So that verifies the gradient theorem. And you can see this is independent of path. Gradient v dot dl is always independent of path. So along both paths, we have verified that gradient v dot dl is same. Is it clear?
Yes, sir. Clear.
Yes.
Now let us see last case. You can also calculate along third path C. So along C part, just see x, y, z. They all varies from 0 to 1. So they have same variation. So it means we can take x is equal to y is equal to z, and then dx is equal to dy is equal to dz. So dl vector we can write as dx x cap, dy y cap, dz z cap. So let us convert it in variable x only. You can convert either x or y or z. So I am converting it into x. So we will get dx, this is x cap plus y cap plus z cap. Now what will be gradient v dot dl? You have to put y is equal to x and z is equal to x. So you will get these two terms, twice x plus 4y dx plus 4x twice z dx plus 6y z square dx. Put y is equal to x, so 2x plus 4x dx plus 4x plus twice x cube dx, and last term is 6x cube dx. So let us calculate these values. if you integrate this gradient v dot dl, so this integral with respect to 0 to 1, you have to integrate this 0 to 1. So this is 6x. So that will give you 6 x square by 2. So 1 by 2 plus this will give you 4 into 1 by 2 plus 2 into 1 by 4 plus 6 into 1 by x cube by 4. So what will be this value? I think this gradient v is 4x plus twice z cube. So is it clear? X power
Okay, sir.
4 by 4. So what will be this value?
7, sir.
What will be total value?
7, sir.
7.
Is it 7?
Yes, sir.
Why this is 6 by 4 will give you, what will
3
be
by
this?
2.
3 by 2. So this value
Yes,
is
sir.
3 plus, this
2
is
plus
2 plus 1 by 2
1 by 2.
plus 3 by 2. So this is 3 plus 5 by 2 plus 3 by 2. So that is 7. So again you can see along each path gradient v dot dl is same, and that is same as vb minus va. So that verifies the gradient theorem in Cartesian coordinate system.